Welcome to my project whatsapp.com. The title is Fault Tolerant Localizations and Tracking of Multiple Sourcing Wireless Sensor Networks Using Binary Data. Go to abstract. A fault tolerant localization and tracking algorithm for multiple event source in wireless sensor networks using only binary sensors observations. The proposed algorithm FTLT means fault tolerant localizations and tracking has the following three main phases. One is identifications and localizations and smoothing. In the identification phase, all alarm sensors know broadcast their status in your own neighborhood. We have chosen to focus on the simple and minimalistic setting of binary sensor because the cost and power consumptions of sensor node is a so constraints in large scale deployments, and both can be significantly reduced by restricting the nodes to provide binary reductions. And then our focus in this paper is on the efficiency of collaborative tracking rather on the communications protocols used by the sensor nodes. Thus we assume that all of sensor reading are available at the centralized processors, which can then estimate the target locations and trajectories. Distributed implementations of our algorithms in which neighbors collaborate to estimate segments of disastrous are possible but are not considered here. We develop a practical filtering algorithm based on a cost functions that personalize changes in velocity, and extensive set of simulations as well as experiments with passive infrared sensors are reported. And proposed systems. The proposed approach is distributed in nature, which allows for real-time tracking and scalable implementations. In particular, our results indicate that FTLT can accurately identify, localize and track all target in the fields, avoiding at the same time the creations of spurious tracks even when as many as 25% of the sensor nodes report erroneous observations. The efficiency criteria for an accurate target count in a one-dimensional setting and provide a routing algorithms that determine the minimum number of targets that is consistent with the sensor reading. The simple and minimalistic settings of binary sensors because the cost and power consumptions of sensor node is so constant in large-scale deployment, and both can be significantly reduced by restricting the nodes to provide binary reductions. More recently, we have developed a fault-tolerant maximum likelihood estimator, and its performance closely approximated by the subtract and navigate Addon positive SNAP as proposed in our earlier work is a centralized process in the sense that it constructs a scoring matrix over the entire field utilizing the binary informations from all sensor nodes in the field. The project flow is first used to create the root node and subnodes and getting the IP for root nodes and subnodes, creating of all these nodes and generating the circle formations of nodes. Search a neighboring node. One data can send from source to destinations and identify the enormous data by using fault tolerance reductions. There are three phases are used in this project. One is identify and localize, another one is tracking. By using routing algorithm, final data has been received. Let us see the demo. First user create the root node and get IP. Enter the username and password. IP created. These details are stored in database. This one is network deployment. I will create the 5 nodes. Go to get connections. Enter the source node. I give 1. Specify the blue color and enter the destination node. I give 5 and go to next. This one is source frames. Go to get IP. Browse the one text files. Now I will select the hi.text, open these files, and this data can send from source to destinations. File has been sent, and node routing informations. This one is destination process. Calculate the distance. Node distance calculated, and show values. Go to next and path this node details. Source node is 1, destination node is 5, and intermediate node is 2. Got the node separations, and nodes are separated. This one is identifying fault nodes, and fault node is 2. Get alternative path, and routing tables are altered. Calculate the distance. This one is fault tolerant localizations and mobile tracking, and go to start simulations. Distance between two mobile trackings, and go to transfer, enter the source, and enter the destinations. Go to angle of arrival. M1, M2 up to M6 is also a mobile tracking, and calculate the distance. M1 is nearest on base stations 4, and calculate this mobile tracking distance, and go to target locations. Finally, velocity for nodes also calculated. Only source and destination process. Go to fault tolerant localizations, mobile tracking. Fault tolerance also reductant. Fault tolerance also reductions. And connection terminus points are mobile tracking 1 and mobile tracking 5. And routing path from 1 to 5 is base station 1, and go to next. This one is fault tolerant using binary data. Go to reductions, and attack reductions for fault tolerance, and finally show this binary data, and evaluations of existing proposed systems, and go to next. This one is destination process. Data has been received, and go to effective comparisons between existing and proposed systems. Red color is existing, blue is proposed systems. And time comparisons. Proposed time will be decreased, and existing time is also increased, and executions is milliseconds. Thank you.